Hi everyone, today I'm going to talk about ATM, MPLS, interserve, and diffserve. So firstly, let's talk about ATM. ATM is the abbreviation of a synchronous transfer mode, which is a switching technique used by telecommunication network that uses asynchronous time division multiplexing to encode data into small fixed-size cells. This is different from Ethernet or Internet, which use variable package size for data and off-ramp. The fixed size of cell could make switch design and achieve high speed much easier. Cells are transmitted asynchronous and high speed as circuit switch network was less efficient because when there's no communication, the circuit is remaining idle and bandwidth is wasted. So the ATM tried to address that problem using statistical multiplexing. That means the size of cell is fixed and the cells can be pushed in any order by the end station. The network will be connection-oriented. This was necessary in order to accommodate the quality of service. ATM can handle both constant rate traffic and variable rate traffic, thus it can carry multiple types of traffic with end-to-end quality of service. For ATM cells, each cell is 53 bytes long and 5 bytes of header and followed by 48 bytes of payload, and this part we will mention later. So the header is composed of 6 elements. The GFC field is the 4-bit field that was originally added to support the connection of ATM network to share access network. The VPI defines the virtual path for this particular cell. The VCI defines the virtual channel within the specified virtual path for this particular cell. The PTI is a 3-bit field. The first bit indicates the type of ATM cell that follows. The second bit indicates whether the cell experienced congestion from source to destination. The third bit indicates the last cell in a block for AL5 in user ATM cells. The CLP field is the 1-bit field used as a priority indicator. The HEC field is the 8-bit field that allows an ATM switch or ATM endpoint to correct a single bit error to detect multi-bit error in the first 4 bytes of ATM header. ATM use virtual paths and channel to logically divide the bandwidth of transmission paths. For virtual paths, the bandwidth of transmission paths is logically divided into separate virtual paths and identified using the VPI in ATM header. Each virtual path is allocated a fixed amount of bandwidth. Virtual paths do not dynamically vary their bandwidth beyond what has been allocated. As for virtual channel, the bandwidth of virtual paths is logically divided into separate virtual channels using a virtual channel identifier in the ATM header. Unlike virtual paths, virtual channel shares bandwidth dynamically within a virtual path. MPLS is the abbreviation of multi-protocol label switching, and the fundamental concept is the label package. And here is the terminology of MPLS. Next, let's talk about the operation of label switching in MPLS. As we can see from Figure 1, the ingress areas are received the IP package with destination of 2.2, classified it into a FEC, and labels it with the label according to the FEC L1. The FEC corresponds to a traditional destination subnet. After that, the cool areas are received the package, use the ingress label as an index into a lookup table, and thus ascertains the egress label and interface on which to forward the package. Next is the egress areas are received the package, remove the label, and perform a traditional layer 3 routing lookup to forward the package to the final destination. And the reason to choose MPLS is that first, ATM as the backbone transmission technology has a scalability problem as shown, and simple IP routing could not meet the requirement for quality of service and efficiency. Next is the final chapter about quality of service. The main QoS requirements are bandwidth, reliability, and delay. And here I will talk about the two different services, which are integrated service and differentiated service. And for the integrated service, I will focus on RSVP. RSVP is a resource reservation protocol, which is a transport layer protocol that enables a network to provide different levels of service to specific flows of data. As different applications have different network performance requirements. For example, email requires reliable delivery but not timeliness of delivery. But video call must be timely but not necessarily reliable. RSVP is not a routing protocol, but it works in conjunction of a routing protocol. Implementing RSVP is an existing network did not require migration to a new routing protocol, and RSVP use soft states and support group communication. Unlike integrated services, differentiated service does not offer any end-to-end quality of service guarantees. It may give only in certain domains in between, And the diff-serve network does not define any service model, it only defines forwarding treatment. And here's the reference. Thank you.